Fine. Here we go, chapter 2-6, rational functions. Rational function is any function in the form of n of x divided by d of x. In other words, it's a fraction. For n of x and d of x are polynomials, and d of x cannot be 0. Why can d of x not be 0? Because if you divide by 0, it makes the fraction undefined, right? Clear? Yes? Okay. Now, domain is all the x values except the values that make d of x equal to 0. In the function, f of x equals n of x over d of x. In other words, if I'm looking for the domain, I'm looking for all the holes in the graph. Do we understand that? Where there's not a corresponding y value. In other words, I have an x value, but I have a hole in the graph. I don't have a y value that goes along with it. An asymptote is a place where a graph cannot touch or cross. These are equations. Now, an asymptote is an equation. It's either a vertical line, horizontal line, or a slant line. Vertical line is in the form of x equals a, or x equals a number. A horizontal line is going to be y equals b, or y equals a number. And a slant asymptote is going to be in the form of y equals mx plus b. And I see many of you not writing down the things that I do not have on your notes. You might want to do that. Now, an asymptote is a line, an imaginary line, that the graph gets really, really, really ridiculously close to it, but never once does it cross it. Do you understand that? So it's this imaginary boundary line that if you touch it, it's kind of like you get shocked. Like if you'd be out in the woods and there'd be an electric fence there. If you touch the fence, what happens? You get shocked. Okay? It's going to be on.
If you're grounding out. What if it's a...
Seriously, no. No. In our world, you touch it, you get shocked. Okay? To house you people in it. A vertical asymptote. Vertical asymptote is any equation in the form of x equals a. And these are all equations in the form of x equals a, where a is the 0 of d of x. In other words, it's the 0 of my denominator. In other words, if I set the denominator equals 0 and solve for it, that is going to be my lovely vertical asymptote. Okay? However, before you can find your vertical asymptote, you must first reduce f of x. In other words, if you can factor it and cancel things out, you want to do that first. Do we all understand that? Horizontal asymptote. A horizontal asymptote is going to be a horizontal line, y equals b. And it is going to be found by first locating the degree of the numerator, n, the degree of the denominator, m, and comparing them. Whenever I say you're comparing them in the form of less than, greater than, or equal to. So since I have less than, greater than, or equal to, I have 3 separate cases. Do we understand that? So if the degree of my numerator, n, is less than the degree of my denominator, m, then that means I have y equaling 0 as my horizontal asymptote. No thought required. I immediately just say, okay, y equals 0 is my horizontal asymptote. If n is greater than m, then I have no asymptote. And the reason why is because that's going to be my slant asymptote case. Okay? Do you understand? Then we have case 3 where it says, well, what if they're equal? If the degrees are equal, the degree of the numerator and the degree of the denominator are the same. Everybody with me? Then you have to compare their leading coefficients. The leading coefficient of my numerator, n of x, is equal to a sub n. The leading coefficient of my denominator, d of x, is equal to b sub m. Why do they label them like that? I don't know. Are we going to worry about that? No, we're just going to memorize it. Yes? Then you're not going to do well. So I have my horizontal asymptote being my leading coefficient divided by the leading coefficient of my denominator. So let's jump right in, shall we? I've talked about 3 things today. I've talked about domain, vertical asymptote, and horizontal asymptote. Those are the 3 things you are going to find on every problem today. Everybody with me? So I give you f of x equals 2x squared divided by x squared minus 1. It is a UV. I'm glad you felt that way. So step 1, I need to find the domain. How do I find the domain? I need to find my domain, and my domain comes from d of x cannot be 0. And I'm going to put does not equal to 0 because that will immediately let your restrictions fall out. Do we understand what I just said? So what's my denominator? My denominator is x squared minus 1 is cannot be 0. Now, your brain may work two different methods on here. How many people right now want to solve this by adding 1 to both sides? How many people want to factor that into two binomials? Either one is correct. Okay? I am going to go with adding 1 to both sides. So I have x squared is equal to 1. Now how do I solve for x squared? Take the square root, and I have x is equal to plus or minus 1. And it cannot be that. Which means now I have a domain restriction. If I let x equal 1 or negative 1, and I square it and add 1 to it, what's going to happen? Or subtract 1 to it, what's going to happen? It's going to be 0 in the denominator. Can we add a 0 in the denominator? No, which means my domain is going to be that x is an element of the reals, but x cannot be plus or minus 1. Because if it is plus or minus 1, I have a 0 in the denominator, and that is not legal. Do we all understand that problem right there? The next thing we need to find are vertical asymptotes. Well, vertical asymptotes are going to be the imaginary lines that things get very, very close to but never cross it, right? Now, it is all the equations in the form of x equals a, where a is the 0 of d of x. It's the 0 of d of x. But what was the restriction that I talked about earlier? Could I do it right away, or what was I forced to have to do? It says right here that I need to reduce f of x first. If I don't reduce f of x first, in other words, factor it and simplify it, then I'm not going to get the correct vertical asymptotes. Okay? So, what are my possible vertical asymptotes so far? Well, I can look at my domain and say, well, whatever my restrictions are, those have to be the only vertical asymptotes that I can have. Do we understand that? So I can have x equals 1, or I can have x equals negative 1. How do I know if I'm going to have both of them? Well, I'm not going to know until I see if I can reduce this. In other words, is f of x, can I factor that? Can I reduce it? Can I factor 2x squared? Nothing that's going to be helpful, right? Can I factor x squared minus 1? Yes, I can. X plus 1 times x minus 1. Does anything cancel out? No. Which means this is as far down as it possibly can go. Do we understand that? Which means now I'm going to take my denominator, which is d of x, and I'm going to set it equal to 0. So that's x plus 1 times x minus 1 is equal to 0. And now I have my two lovely little, and yes, I'm showing all my work even though it's killing me right now. Here are my two vertical asymptotes. Why did they turn out to be exactly the same thing as the domain? Could I reduce f of x? No, since I couldn't reduce f of x, then my domain restrictions will be my vertical asymptotes. Since I could not reduce f of x, my domain restrictions will be my x-intercepts. I mean, my x equals the number of my vertical asymptotes. Do we get that? Okay. Next, horizontal asymptotes. Well, whenever we're dealing with the horizontal asymptotes, what do I have to compare and contrast? Horizontal asymptote is y equals b. And all horizontal asymptotes are based off of what? It's the thing highlighted in yellow, y'all. the degree of the numerator and the degree of the denominator. So now I'm going to come back here and I'm going to say, okay, well, what's the degree of the numerator? The highest degree of the numerator is 2. What's the highest degree of the denominator? 2. Now, are they the same, less than, or equal to? Well, I'm going to come down here and I'm going to label these just so that we know. N is equal to 2 and M is equal to 2. Now compare them. N is what compared to M? They're equal. Since they are equal, I come back over here and I say, is that case 1, 2, or 3? That's going to be case 3. So if case 3 tells us, I now have to compare what? The leading coefficients. So I'm going to have a lovely little equation of y is equal to a sub n over b sub n. What's a sub n? A sub n is going to be the leading coefficient of the numerator. What's b sub n? B sub m, sorry, is going to be the leading coefficient of the denominator. So what is that? 2 over 1. There is a 1 there, which means now this thing is going to be a 2, this is going to be a 1. So I have the equation y equals 2. Well, this is all great. We've talked about the domain. That's magnificent. How in the world does that help me graphically? Well, why does this help? Because if I were to graph this thing, what was my function? 2x squared
over x squared.
Do you see there's my function? Now, what was I supposed to have at x equals negative 1? What? What was I supposed to have at x equals negative 1 and x equals positive 1? A vertical asymptote. So if I hit menu, trace, graph trace, and if I hit 1, do you see that dotted line that had just appeared down there? Do you see the ordered pair says undefined? Undefined means it does not have a corresponding y value, which means there's a hole in the graph there, which means it's a restriction in the domain. Do we get that? What else it tells me is that look at the graph down here on the left, or on the right. This arm of this parabola between 0 and 1, it's a decreasing function, and it's getting extremely close to what value? 1, but is it ever going to cross it? No. Okay? And I can actually hit Control-T, and I can look at my values between 0 and 1, and I could change this table, edit table, 1, menu, table, edit table settings. I want it to start at 0, and I want it to go by 0.1s, and hit OK. Look what's happening. Oopsie. I went way too far. Look what's happening between 0 and 1. Look at that, the y value. It's decreasing, 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 but it's never, ever, 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 ever going to be on the value 1. Okay? 1 is never, it's never going to get. Do you see how it's undefined here? It's undefined right at that value of 1. Okay?
So how does it get 1 to go 1?
Because it goes to this side of it over here. Okay? After that, in between, yeah. Okay? At 1, it's undefined. Okay? But then what happens is it now skips over to the next part of the graph and it goes to this part over here, that little L shape or whatever, and it has to graph that section of the graph. Okay? Now what's happening at 2, at y equals 2, my horizontal? So if I graph y equals 2, do you see that? Okay? It almost lands on it. It gets so darn close to it. It is going to be looking like it's 2. It's harder for the vertical asymptotes. You can't see the table very well. But if I come over here and I hit Control-T,
How do you get one?
it's because yours isn't going to do that. Oh, mine. It's yours.
Why, like, is there open space for work? You know, there's no other horizontal line.
Repeat that louder.
Why is there open space below 2, and there's no other horizontal asymptotes? There's no other way that the graph will go past.
There's open space between 0 and 2. Okay? What you have is 3 sections of a graph here. You have a section of a graph that hits up to the value -1, which is going to be this part of it, that left-hand side. Then what happens between -1 and 1 is you have this part down here where this asymptote does not come into play. And then over here you have another asymptote after 1 where this part of the graph has to apply to 2 of the asymptotes. Okay? So if I look at the table, and this is the beautiful thing about the y values, the y. You're down. Control T.
Horizontal line at 1, and they would still never touch it because it's still always have to go down.
I don't understand what you're saying. Repeat it one more time. There's one horizontal asymptote. You can only have one horizontal asymptote.
Yeah, but I'm saying, like, why is there 2 whole units below the horizontal asymptote that no graph would touch? What graph would touch in between the horizontal asymptote and down below 2?
You'd have to make it a piecewise function for that to happen. Like for you to create something like that, you'd have to have a piecewise function. You'd have a domain restriction on that. In this case, this example, there is not anything below -2 except for in between your domain restrictions of -1 to 1. That's the only thing that you're going to have. And the reason why it's 2 is because the leading coefficient of my numerator was 2. The leading coefficient of my denominator was 1.
Oh, yeah, I get it.
That's why you have that equation. Okay? Now, if you are looking at a value for x that's below -1, what should it be approaching every time? It should be approaching 2. Do you see how it's approaching 2, but it's still greater than 2? Do you see that? Why does it have to be greater than 2? Because it has to be above the value of the y-intercept, or the y-asymptote. Not the y-intercept, the y-asymptote. And over here, as x gets really big, and whenever I say really big, I'm talking about, let's do 50. Do you see at 50, and then 51, 53, do you see how it's still going to get approached 2? Okay, it's getting smaller, it's getting closer to 2, but it's never going to cross it. No. Let's do the whole process all over again. Okay, so letter A, I need to get my domain. Domain. How do I find my domain? D of x cannot be 0. So I have 3x squared plus 1 cannot be 0. So 3x squared cannot be -1. X squared cannot be -1/3. Now how do I get rid of that squared? Square root it. And whenever I take the square root of a negative quantity, what number system am I falling in? Imaginary. Now, folks, I'm graphing this in the real number system, correct? So what's my domain? My domain is x and the real because there's no real restrictions. Do we understand that? There's no exclusions in the real number system. Do we get that? Because whenever I solve d of x and set that not equal to 0, the only restriction it's going to give me is a restriction in the imaginary number system. So my next question to you is do I have any vertical asymptotes? Where did I tell you your vertical asymptotes come from? From your restrictions in your denominator. If I have no restrictions in my denominator that are real, am I going to have any vertical asymptotes that are real? No. Why? Because it's in the imaginary number system. Do we all understand that? Letter C, my horizontal. Well, how do I know if I have a horizontal asymptote? I look at the degree of the numerator, which is 1. I look at the degree of the denominator, which is 2. Correct? So now what is going to be my lovely little asymptote? Well, n is going to be 1, m is going to be 2. So what is the relationship between n and m? N is less than m, and since n is less than m, is that case 1, 2, or 3? It's case 1, so what's my horizontal asymptote? Y equals 0. So if we come back over here and if we were to graph that, what was that one? 3x squared plus or minus? Is it minus? Okay. Now, what this means is the only thing I'm going to have here is what? A horizontal asymptote at y equals 0. Is it ever going to land on 0? No. Can you see that the x-axis is going to be your lovely little horizontal asymptote? Okay, moving on. Next, what do I do? Domain. D of x cannot be 0. So x squared minus x minus 6 cannot be 0. X minus 3. X plus 2 cannot be 0. X cannot be 3. Cannot be negative 2. Right? That is your domain. So just put x's and them with the reals in front, and then put an and sign in between, and you're good. Asymptotes. Vertical. What are my only two options for a vertical asymptote? 3 and negative 2. So how do I conclude if those are actually working values? I have to simplify this. So this is going to give me x plus 2 times x minus 1 all over x plus 2 times x minus 3. What happens there? The x plus 2's cancel out, and what I have is x minus 1 over x minus 3. That is my reduced d of x. Where do my vertical asymptotes come from? My original f of x or your reduced f of x? They come from your reduced. So I'm going to take my reduced, just so that we're all clear on this. Reduced d of x cannot be 0, or can be 0, sorry. So that's going to be x minus 3 can be 0, so my vertical asymptote is going to be at x equals 3. Now, what does that mean for x equaling negative 2 in my domain? What does that mean for x equals negative 2 in my domain? Graphically, think about that. There's a hole at negative 2, but is there an asymptote at negative 2? No. What happens at 3? There's a hole at 3 and an asymptote at 3. Do we all understand the difference? Okay. Now the horizontal asymptote. Horizontal asymptote, what am I comparing? The exponents of the Numerator and the denominator, they're both the same, so now what do I compare? The leading coefficients. And the leading coefficients are what? So n is 1, m is 1, or were they 2? Which means n is equal to m. So that means I have to use a sub n over b sub n, which is 1 over 1 to give me my equation, y is equal to 1. That was the degree of the numerator and the degree of the denominator. Degree. Since the degree of the numerator is 2 and the degree of the denominator is 2, they're equal to each other. That means I have to look at the leading coefficients. The leading coefficient of the numerator is understood to be 1. The leading coefficient of the denominator is understood to be 1. So that's why I have y is equal to a sub n over b sub n, and that gives you 1 divided by 1. Okay? What does this look like graphically? Well, that was going to be x squared plus or minus x.
Plus x minus b.
Thank you. Over
X squared minus x.
minus x minus 6. Do you see it? Now, let's think about this a minute. Where is my vertical asymptote? At 3. So menu, analyze or trace, graph trace, and hit 3. Do I have a vertical asymptote there? I sure do. It's never going to touch it. It gets really darn close to it, but it's never touch it. No. Okay? Next thing. -2. What happens at -2? There's simply a hole in the graph, right? It's not approaching it. It's going through it with a hole in it, right? So I don't have an asymptote at -2, but I still have a hole in it. So my domain's correct. Now, what's the next thing I should be looking at? 1. In other words, I'm going to hit tab, and I'm going to type in 1, and I'm going to graph 1. Is it approaching 1 on both sides? As x gets really big, it's going to approach 1. It's never going to cross it. As x gets really small, what's going to happen? It's going to approach y equals 1. Do we understand that? Yes or no? Okay. Tonight's homework is 1 through 22, all problems 1 through 6. What do I want you to do? I only want you to do B and C. I don't care about the table of values. So I want everybody to get their books open to page 149.
You want us to record the holes?
Sorry?
You want us to put down where the holes are?
Well, you have to put down where the holes are because that's the domain, right? Nope, I put all the books away because all of my pre-calculus were no longer bringing their textbooks to class. So I went ahead and I made sure I got rid of all the textbooks so you have no choice but to bring your textbook to class today. Aren't I evil? Sorry. Okay, for problems 1 through 6, it says A, complete each table. You don't have to do that. B, determine the vertical and horizontal asymptotes. You do. And C, the domain. Now, for problems 7 through 12, it says match the function with its graph. Do you need to graph these functions on a graphing calculator? No. What should you be able to find and easily match with? What are we talking about today? Vertical and horizontal asymptotes. So all you have to do is find the vertical and horizontal asymptotes, and should you be able to match those 6 graphs together? Yeah. Now the next set of instructions, 13 through 22, it says find the domain of the function. That's easy. B, identify any horizontal and vertical asymptotes. And C, verify your answer to part A, both graphically by using graph utility and numerically. Okay, I do want you to work back and forth on the graph on those things at the end of the table. I want you to see it. Are you going to have anything to write down on that part? No. But if you don't help yourself out and get familiar with how to look at this graphically, you're not going to do well on the test. Do we all understand what you have to do tonight for homework? Now, when we are back, we're back on Thursday. Okay? We're probably going to be moving on to the next section. The next section is going to be graphing slant asymptotes and finding those. The whole point of this section is for you to be able to take all of this information, domain, vertical, horizontal, and slant, and be able to graph a function with all that information. Okay? check that. Friday, I will not be here. So Friday, you guys will have something that you guys are going to have to do by yourselves. Okay? Get busy on tonight's homework.